Hey guys, good morning. Welcome to homework help for web assignment number 6. The two questions that I imagine you're going to have the most difficulty with have to do with this duffel bag problem and the block on the ceiling problem. So I just wanted to give a little bit of a hand there when it came to that. I'm not going to go all the way through and solve to the very end, but we should be able to figure out a decent amount here. So really critical would be a good free body diagram. And we're going to start obviously with the object on the incline, and that would give us some help when it comes to knowing what we're doing here. So let's begin. Whoops, there we go. As we know, this is going to be mg. We have a normal force going this way. We've got a friction force, and I know that because of the coefficient of friction question. That one is going up the hill. We don't have any tensions. We don't have anything fancy going on with this bag. All right, but the first one has to do with calculating the normal force. So a couple of quick reminders. The only one you're going to actually break up into components is going to be your gravity. All right, your angle here is going to match your angle here. mg sine of theta is what's going down the hill, and mg cosine theta is actually opposite your normal force. So these two should match. That'll take care of number one. Calculating the net force, this particular question not only gives you the mass of your object, but it also gives you the acceleration of your object. And so I would draw your attention to Newton's second law for that one. The hardest question by far is this final one. Calculate the coefficient of kinetic friction between the incline and the bag. And the reason that this one is difficult is because you're used to doing this. You want to say friction over normal. And that's not a bad way to go. I mean, we're going to ultimately need that anyway, right? But we need to know what friction is. And you may consider, you may think, oh, this one and this one are almost always equal to each other because that's what we've done in all the other problems. But you would be incorrect in this case. And the reason for that is because this is an unbalanced force, right? We are accelerating down the hill. And if we're accelerating down the hill, what that means is that we do not have equal and opposite forces going up the hill and down the hill. This is where we have to use our relationship of net force being the bigger force minus the smaller force. So you have to ask yourself, what's the bigger one? Well, which way is it accelerating? It's accelerating down the hill. So that's our bigger force. Our smaller force is going to be friction. And those two things together will equal the mass times the acceleration. Your goal is to use this relationship to find the friction force. At this point, it's algebra. So we should be able to do that pretty easily, I hope, after that. So hopefully that gives you an idea about that question. Let's move on to this question. This one, we're given a mass and a force on our we're pushing up against the ceiling. And that's actually a little different than what we're used to. They give you the angle here, and that will allow you to figure out what you need to know there. You know the mass of the block. You're given an acceleration. Okay, so right away you can find your net force. That's always a good thing to know. All right, again, we're looking for the coefficient of kinetic friction. So let's see. We have a constant applied for a free body diagram. A free body diagram is what we're totally going to need. And ultimately, we need these two values in order to find our coefficient of kinetic friction, right? So let's consider the free body diagram that we're dealing with. So we've got F going up at this angle, right? And if it's at an angle, then we know we're going to have components. So let's consider we have a piece going this way and a piece going this way, right? So let's call this the X piece and this the Y piece, because that makes life a little bit easier. Now let's consider the other forces that we know about. There's always gravity. And we do have a surface, so we are going to need to consider the normal force. But let's think about this, okay? Normally, well, generally, let's not use the word normally, right? If you are pushing, if you have something that's sitting on a floor, right, and I say draw the free body diagram, you always give me gravity with no trouble, and then you give me normal force going this way. So your instinct might be that it's always going to be up, it's always going to be down, or it's always going to be in a certain way, but that's actually not true. This force is the reaction of the floor to the push, to the pull of gravity. This is the reacting force up from the floor onto the block. So let's consider what we're doing here. This block or this object is being pushed against the ceiling. It's being pushed this way against the ceiling. So guess which way the normal force goes? It goes like that. Oh dear, that is very different than what we're used to. Okay, but keep in mind it's a reactive force. So when we look at the acceleration of this object, let's consider where it's moving. If you're pushing it like this, you know the acceleration is going to be going in this direction. That's got to be your bigger force. Your friction force would have to be the opposite direction, right? This is going to be my bigger minus smaller. Fx minus, man, this board is wobbling, so I apologize for it not being as clear as it should be, right? But my net force is going to be equal to, good grief, you can't read that. I'm sorry, let's try that again, shall we? My net force is going to be equal to my bigger force, in this case that will be the x direction, minus the resisting force of the friction, which is over here. And of course we want this. So we can find this, and we can find this, and we know these. So it's actually very similar to the previous problem for finding the friction. Finding the normal force maybe is a little more ambiguous, perhaps is the right word. But this block is not going up into the ceiling or sinking down to the floor. So keep in mind that all of the arrows pointing upward have to equal all of the arrows pointing down. And you have an arrow pointing up here, and you have two arrows pointing down there. So that will allow you to figure out the normal force. All right, so hopefully you found that helpful, and come see me if you have any other questions.